I don't know how much you guys see. Do you guys know what an absolute value is? Like, does that mean anything to you? Because I think they've removed it from some of the Algebra 1 curriculum. You might not have seen it. Perfect. That's the textbook definition. Excellent. Okay. So absolute value is distance from a number to 0 on the number line. That is the actual definition of an absolute value. Distance from a number to 0 on the number line. Does anybody else think, like, do you think of anything else when you think of absolute value? Like, it has to be what kind of a number? It has to be positive. Perfect. Okay, so keep that in mind. Distance is always positive, so if we're measuring the distance from a number to a number line, or a number to 0 on the number line, it has to be positive because you're measuring a distance. Okay, now, I have a tiny little equation here to the side. I was just going to show the number. Actually, let me draw this real quick before I move on to that example. So if I'm at the number, if I take the absolute value of 2, so here's 0, here's 2, that distance would be 2 units. But if I were to do, for example, let's say we did absolute value of -3. Here's -3 on the number line, but to get that to 0, if I actually measured the distance, that's 3 units away. So distance is always positive, so that's why that's going to be a positive number. If you get a negative number inside absolute value, the absolute value cancels it out. If you have a positive number, it just stays positive. So keeping that in mind, I'm going to have us work on some equations today. That's going to be our goal. We want to solve absolute value equations. There's kind of 2 types. We're going to do one type on the front, one type on the back. But I just have a teeny tiny, just absolute value of x equals 4. So here's an example absolute value equation. That symbol, those little 2 vertical bars, that's your absolute value symbol. So that's saying absolute value of x equals 4. Does anybody know what the answer to that equation is? Hunter, what do you think? Yes, it could be 4 or it could be -4, because if I take my absolute value, that'll cancel out the negative. So these questions are going to have most of the time 2 answers, and sometimes you might have to check. We're going to get into that a little bit more today. So what you want to do anytime you're solving an absolute value equation, and we're just going to start with a couple in example 1 here. First thing you want to do is get, I'm going to just write ABS value alone. That's the first thing you want to do. Get the absolute value alone. Maybe some algebra skills to do that. And then I'm going to show you what to do from there. But that should be the first goal. Get the absolute value alone. Okay, so in my very first question here, I have 15 minus 3x, absolute value of that equals 6. So I have the absolute value alone. All right, now, it doesn't matter what's in here. It doesn't matter. If that was, if whatever's in there was 6, we'd be good, or if it was -6, we'd be good. So what you're going to do, you're just going to drop the absolute value, and we're going to split this into 2 equations. So I'm just going to literally drop the absolute value, just copy that lovely equation exactly as it appears. But there's 2 possible answers here, because 6 or -6 would both work. So then all I'm going to do, again, I'm just going to drop the absolute value. I'm doing 15 minus 3x. And then for my second possible answer, we just set that equal to -6. So it's the positive or negative version of whatever that number is. And then you just solve them, just like normal algebra. So a lot of the times the algebra steps are pretty similar in the 2 equations, but you don't get the same answer. So on the first one, if I subtract 15, I'm going to get -9 divided by -3. X is going to be 3. If I take the second equation, I'm going to kind of do the same steps. I'm going to subtract 15. But now on this one, I have -3x equals -21. Divide by -3. And then x is 7. Okay, so what this means, and these are easy if you want to check. So if I plug in 3, that means whatever's inside that absolute value would become 6. If you want to check like 15 minus, and you don't have to use a calculator to do this, but 15 minus 3 times 3, in that absolute value, that'd be 6. Absolute value of 6, say 6. If I put in 7, what that means is the inside of that would be negative 6, but that still solves that equation. So if I plug in 7, you see I get negative 6, then the absolute value would cancel, bless you, cancel that out and make that equation true. So this has 2 answers. Is anybody having a question at the moment? Okay, now, if your absolute value is not alone, which is what I have going on in these other 2 problems, the first goal has to be to get the absolute value all by itself on one side of the equation. So I've got here 4 minus, and then I have 2 times absolute value of x plus 9. That's equal to negative 16. So if you're trying to get the just treat the absolute value like it's a giant variable. If you're trying to get that absolute value alone, does anybody know what I might do first? I'll isolate the absolute value. What would we do first? Yes. Okay. And I had somebody last period, don't do this, I put this on here on purpose. They did like 4 minus 2. Don't do that. You would have to do the multiplication first in your order of operations. These are being subtracted. So actually what you want to do is just move the 4. So to do that, just subtract 4. So we'd keep the minus sign in front of the 2. Treat that like a negative 2 times the absolute value x plus 9 equals negative 20. Okay, now, very, 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 very important. Never, never, never distribute anything into an absolute value. Totally illegal. Do not do that. So don't distribute. What you want to do is you actually want to divide, because we're trying to isolate this absolute value. Do not distribute anything into an absolute value. Will totally mess everything up. We're just trying to get that absolute value alone, so we're going to divide. So I get x plus 9 equals 10. It's negative 20 divided by negative 2. Okay, now, absolute value alone. Doesn't matter what it is. If inside there was 10, we'd be golden, or if it was negative 10. So we're just going to set up 2 little equations to represent that. So just literally just drop your absolute value, just copy. So x plus 9, if it was 10, we'd be good. Our other option, if inside that absolute value was equal to negative 10, the absolute value would cancel out the negative. So exactly copy that, but I'm going to write down the opposite of that number. And then both of these are just one step. I'm going to subtract 9. So one of my answers is just 1, and then I'm going to subtract 9, and my other answer is negative 19. So what it means, if I put 1, and honestly, if I was trying to check these, I would just back up to the place where you got the absolute value by itself. If I was trying to check this, if I plug in 1, I'm going to get positive 10. If I plug in negative 19 for x, we would get negative 10 inside that absolute value. Okay. Let me have you guys try letter C. Okay, so get the absolute value alone, and then we're going to break it apart into 2 equations. So go through there, see if you can do it. And on any of these, it's okay if you get a decimal or a fraction as an answer, so don't think, if it's not a nice number, don't think you're doing something wrong. Whatever it's equal to, you're just going to copy whatever's in the absolute value, set it equal to that number, and then the opposite of that number. If you want to look, I did mine up there, so if you want to check. And the decimal on that would be, let's see, negative 4.3 repeat. is a decimal. Totally fine. Anybody know what? Okay. Now, I've got an equation under this. I've got an absolute value alone. Says absolute value 3x minus 4 equals negative 10. And I have a lovely box around this to draw your attention to it. And it says, does this equation have a solution, y or y not? Does anybody know why I'm trying to draw your attention to this particular problem? Would you go through and do like 3x minus 4 equals negative 10, 3x minus 4 equals positive 10, or like why am I having you look at this? Do you know? Anybody have any idea? What's wrong with this equation? Absolute, it really doesn't matter what's in the absolute value. Does anybody know what's wrong with this equation? Oh, yeah. It's a negative 10. Okay, so in any case, absolute value makes everything what? Positive. So if you have an absolute value alone and it's equal to a negative number, like this is equal to negative 10, that's not possible. Absolute value can't be equal to a negative number. It can't be because it makes everything positive. So this would automatically be a situation where you have no solution. So if you're going through and maybe you see it right away, like this equation set up right away by itself, but if you go through and you get your absolute value and it ends up being equal to a negative number, you can just stop right there and say, hey, this can't have a solution because an absolute value cannot be negative. It's going to make everything you plug in for x positive. So anything, and I say negative number because we're going to get into a little bit different situation here in a second. Is anybody having a question about this though? Okay, now this kind of potential, absolute value can't be equal to a negative, is going to kind of lead into what we're going to talk about next, which is extraneous solutions. None of the questions that we've done so far would have anything like this because we just had absolute values equal to just a number. If you have an absolute value that's equal to something else, though, we're going to talk about this here real quick. Does anybody know what an extraneous, have you heard this term before, extraneous solution? Yes, no, maybe? Extra solution. Exactly. It's exactly what it is. It literally, so I'm going to write, it's an extra solution that doesn't work in the original problem. When I usually introduce this to people, I literally highlight that it has the word extra right in the word. So the deal with this is, and there's different couple things that we'll do over the course of the year that can potentially introduce one of these. Absolute value is one of them. And we'll do the other second semester. It comes with radicals. Occasionally it might come with a quadratic, but we'll get into that later. So extraneous solution can happen. You did all the algebra right, you didn't do anything wrong, but it doesn't actually work in the original problem. So absolute value is one of the potential places that that can work, and this is the scenario that would happen. If you have an absolute value, it can't be equal to a negative. So there's only one type of equation. None of the ones we've done so far would have a potential for an extraneous solution. If you have an absolute value and it's equal to an expression, so not a plain number, it's equal to an expression. So what I mean by expression, like has a variable of some kind, because you won't know what that variable represents, so you can't tell whether you have an absolute value equal to a negative number or not. Okay, so this is the only situation this can happen. We haven't practiced any questions like this yet. It says you must make sure the expression is not equal to a negative number when you plug in your answer. So when I check these, okay, you have my absolute value all alone, whatever is the expression in terms of your variable. If you plug it in, if it makes that expression negative, that's going to introduce an extraneous solution because we cannot have an absolute value equal to a negative number. If you plug your answer in and this is positive, you're golden. But if you plug your answer in and this expression ends up being negative, any negative number, then it's going to give you an extraneous solution. So all I have here, this is all worked out so you guys can see it, but I just have a little tiny example to the side. So they have 2x plus 12, that's in the absolute value, equal to 4x. This is an expression because I don't know what x represents. So what they did, they're going to break this into two equations, just like we were doing before. You just drop it and copy, and then you drop it and do the opposite. So the opposite of that expression, you would just change the symbol in front. So it's positive 4x, its opposite would be negative 4x. And then you see, they just go through and do these steps. On this side, they get x is 6. And then on this side, they get x is negative 2. Now, underneath, they fully plug this in and show you both sides. What I usually just tell people to do, if you have an absolute value by itself equal to something with a variable, you're just going to plug this in to this expression and check. So if I got 6, 4 times 6 is 24, you're golden. That's a positive number. However, if I plug in the other answer they got, 4 times negative 2, you can see they got negative 8. That is a negative number. So that means that the negative 2 would be what we call an extraneous solution there. The 6 works, and you can see they say yes and no here. So the 6 works, but the negative 2 is an extra answer. So we're going to have that on the back where we're going to need to check. You only need to check if your absolute value is equal to something on the other side with a variable. If it's just a number, you're going to have 2 answers and you don't need to worry about that. All right, so let me have you look at this. So kind of 2 challenges here. I have the absolute value isolated by itself in this very first example. So to set this up, just like the front, I'm literally just going to drop the absolute value and just copy 3x plus 2 equals 4x plus 1. Now, for the other potential answer, I'm just going to drop the absolute value, but now instead of doing like 6 or negative 6, I have to do the opposite of the expression. So if I had 4x plus 1 here, can anybody tell me how they'd write the opposite of that expression? What do you think?
Negative 1 minus 4x.
Yes. As long as and you can write negative 4x minus 1, whatever your preference is, as long as you switch the sign of any of the terms that you have. Now, totally up to you how you want to solve these. If I can, I like to try to keep my variable positive, but you don't have to do that. So if it was me, I would subtract 3x real quick, and then I would go ahead and subtract the 1. So I'm actually going to get 1 as a potential answer here. For the other equation, again, it's just a thing with me. I like to keep my variable positive. So if I was doing this one, I'd add the 4x. So I get 7x plus 2 equals negative 1. Subtract the 2. This one's not going to have a nice answer. I get 7x equals negative 3. And then you divide by 7. So my other potential answer here is 3/7. Okay, now, this is how you check. So you have your original problem, your absolute value all by itself is equal to this expression. So all you have to do, we're just going to plug our answer in real quick. You don't even have to plug it into both sides. Just plug it into that expression. As long as it makes that expression positive, you are golden. So I'm just going to do 4 times 1 plus, I don't know why I just typed that on my calculator. Don't judge. Okay. Doesn't matter what the number is. It just matters whether it's positive or negative. So when I plug this in, it was equal to positive 5. It'll be 5 in here if you plug in 1. 3 times 1 is 3 plus 2 is 5. They'll be the same number. It just matters if this side is negative, because this side will always become positive with the absolute value. So this one, I got a positive number, so we're good to go. That one worked when I checked that. Okay, now I do want to show you one little tiny thing with the calculator because I had somebody run into this morning. So I'm going to check this fraction. I just use, like, if you're using the graphing calculator, not familiar with that, I just use like the parentheses to do a fraction. So the thing I want to point out to you, if you're doing a negative number, you can't use the subtraction key. Like, the calculator will get mad at you and tell you you're doing something wrong. So if you want to do a negative number, make sure you use the negative key. It's right underneath the 3. So I'm just doing negative 3 divided by 7. I just put parentheses around it. Some calculators have a fraction button, some don't. The 83s don't, and that's what I learned with, so I don't usually mess around with the fraction button. But anyway, plugging this into 4x plus 1, add 1 to this. I get this garbage decimal. It does not matter what that number is. It just matters if it's positive or negative. So if this is negative, then, that means this, when I plugged it in, I got a negative number. So this means this is extraneous. Now, I don't want you to think if your answer is negative, that will automatically cause you to get a negative in terms of plugging that into the expression. So just because the answer is negative does not mean it doesn't work. But in this particular problem, when I plug that in, that made that expression have an absolute value equal to a negative. So just be careful. Okay, let's try one more here real quick. So I'm just going to drop the absolute value, just literally copy. It's by itself. I don't have to isolate the absolute value. So I'm just going to copy that. The other equation, we're going to drop our absolute value, so the 2x plus 5. What would you guys tell me for the opposite of the expression x plus 4? Jonathan, what do you think? Negative x minus 4. You're just switching up the sides. Now, however you guys want to solve these, if I was doing the first one, I'd subtract x. So I've got x plus 5 equals 4. Subtract the 5. X is negative 1. So there's a potential answer. My other one, I would add x. So I got 3x plus 5 equals negative 4. I'm going to subtract the 5. So we got 3x equals negative 9. And if I divide by 3, negative 3 is my other potential answer. So I don't want you guys, don't automatically go, oh, they're negative, they're extraneous. It doesn't work like that. You have to actually plug it back in to make sure that you check. So where you want to plug it, just make sure your absolute value is not equal to a negative, because that's an expression. That's why I have to check it. All right, so if I plug in negative 1, I'm not going to use my calculator here. Negative 1 plus 4 would be positive or negative? Positive. It would be 3, right? If I plug this in, as long as this is positive, when you plug it into the expression, that answer will work. Okay, what about this? If I plug in negative 3 to this expression, are we going to get a positive number or a negative number? Positive. So actually, for this question, both of these work. So this question has 2 answers. This one doesn't have an extraneous solution. They both work. And then we're going to try one more. Now, this one does not have the absolute value by itself, so we have to get the absolute value alone. Remember, do not distribute anything into an absolute value. Do not distribute. You want to divide. So to get rid of the 5 in front of that, I'm going to have to divide every single thing by 5 on both sides. So every single term, don't leave anyone out. Everybody gets divided by 5. On the left side there, you'll just be left with your absolute value. So absolute value is 6 minus 5x. And then on the other side, we can actually divide both of those terms by 5. So 15 divided by 5, this would make this 3x. 35 divided by 5 would make that negative 7. Once you've got your absolute value alone, this is where I would go back to check my answer. Don't go back to the original problem. Go back to where you have your absolute value by itself. So this is where I would check my expression. But I'm going to go ahead and break it into those 2 equations. So just drop your absolute value, just copy. 3x minus 7. And then your other equation, again, just drop your absolute value, but now we've got to do the opposite of that expression. So how would I change 3x minus 7 to be its opposite? Jonathan, what do you think?
Negative 3x plus 7.
Perfect. Just change the sign for any of the terms to make that the opposite. Okay, now totally up to you. Again, I just like to keep my variable positive. So if I was working on that first one, I would add 5x. So I get 6 equals 8x minus 7. I'm going to add 7. And this one's not a nice answer. I'm going to get 13 equals 8x. And we divide by 8. So one of our potential answers here, 13 over 8. For the other equation, again, I like to keep my variable positive if I can. I'm going to add 5x again. This is going to give me 6 equals 2x plus 7. I'm going to subtract the 7. So we'll get negative 1 is equal to 2x. Divide by 2. And so our other potential answer there is negative 1/2. Okay, so don't go back to the original problem. Go to wherever you got the absolute value alone. So here's where I want to check. And this one, because I've got fractions, I might go ahead and grab my calculator here. So I just have to make sure my absolute value is not equal to a negative. So we just have to make sure that expression's not negative. So if I do 3 times 13/8, and again, I just use parentheses in the division key to get that fraction, minus 7 Doesn't matter what the number is, it just matters if it's positive or negative. So I got negative 2.125, so this is no bueno, okay? This one gives me, if I plug this in, this gives me a negative number. Doesn't work. All right, now I got to check my other answer too, which is a negative a half. So same thing, I'm going to do 3 times negative a half. Make sure if you're using the graphing calculator, use the negative key, don't use the subtraction sign. It won't do it if you use the subtraction sign. And then minus 7. Again, doesn't matter the number. I got negative 8.5, but that is also bad for us. So that is also negative. That's giving me an absolute value equal to a negative number. So both of my potential answers did not work here. If that happens to you, what would you write as your answer to the question? No solution, exactly. No solution, because both of our answers ended up being extraneous here.